Two topics in this video. We will be covering persistent variables and we'll be covering array and map operators. We hope that after this video you'll have more tools in your toolbox to make more complex applications in Cairo.
In Cairo, there are two types of persistent variables. There are entity variables and application variables. And entity variables are specific to the Pico and the rule set, while application variables are really just specific to the rule set. So both keep persistent data, meaning if I were to just shut off the Pico engine and turn it back on, the application entity variable data would still be there. And we're going to go into specifics on how they differ, right? They mostly differ in scope. So, and we'll show you some examples of that. So here you can see this is how you would initialize a persistent variable. And here it's kind of like the general syntax. And down here I have written, specifically for an entity variable and for an application variable. You can see right here, for an entity variable, you'd write ent colon, and then that variable name, then colon equals, and then any expression. And by that I mean like entity variables and application variables can be any value. They could be maps, arrays, strings, or numbers. But you have to remember that you can only change an entity variable or an application variable in the post loop. So I have this rule right here. It's a very simple rule. All I'm doing is I'm grabbing the test attribute when the rule is raised, right? And I am appending it to my entity variable test and my application variable test, right? And I also have this other rule down here called restart, where I can actually clear those persistent variables. So you can see every time I change the value in those persistent variables, it's always in the post loop. You can't change them anywhere else. You can reference them, right? I can do something like this, and I will get the value in the entity variable, but I can't change it. Another cool thing you can do is in a function you can return the value in those persistent variables. And so if you ever have some application that we're using the Pico engine as the backend, and you want to access that persistent data, you can just create a function that returns that entity variable. So let's test some of this out so that you can see the difference between the entity variable and the application variable. So here I just have this Pico, and I'm on the testing tab, and I wrote some tests beforehand. So let's say I'm going to just use the word Pico, and this should append the string Pico to the entity variable array and the application variable array. So I'll just run it, and then I'll call the get entity variable. You see that it is an array with the string Pico, and the application variable is there as well. Right? Another way you can see your entity and application variables is by going to the rule sets tab, going down to that rule set. You can see they're both listed there. So right now you might think, well, they're essentially the same thing, and really they're not. So like I said earlier, the entity variable is specific to the Pico and the rule set, while the application variable is specific to the rule set. So if I have another Pico right here, Pico 2, and I was to install that same rule set, you'll see if I look at the entity variables inside, there is not one, but there is an application variable, and it's the same one that this Pico has. And that's because they're sharing that data, because it's specific to the rule set and not to the Pico like entity variables are. And so if I were to, let's say, append another word, let's say Pico 2, I can see that, look, I have that array with 2 strings in it. Go to the application variable, it's also there. Let's go look under the rule sets tab, right? Both have the value, but if I were to go to this Pico. I'll refresh it. Right, I haven't messed with its entity variable test at all because I haven't touched that rule in this Pico. But because it's sharing this application variable, right, it does get that Pico2 string on there. And if I were to do it here, right, I'll say Pico 3 or something like that. I'll refresh. Right, the application variable has all 3, and the entity variable just has the 1. And we should see the application variable in this Pico also have the 3, but only have 2 on the entity variable. So now, hopefully that can help you see the difference between the two. It really is about scope. So you guys might have thought, well, when it comes to the entity variables, right, this syntax right here, it's terrible, right? You don't want to have to do a dot defaults to for every rule, because maybe you already want to have this entity variable be the empty array. There's actually a really easy way of doing that. You can write a rule that can work as like an initializer. So I'm going to uncomment this rule real quick. You'll see that it selects when Wrangler rule set added, and I'm checking the attributes, the rids attribute, and I'm checking if the current rule set that I'm in, if it's included in the rids attribute. So this rule is found in io.picolabs.wrangler, and it's raised every time a rule set's installed. So what I'm saying in this rule is, hey, I want to raise this init rule if my current rule set is found as one of the rule sets that has been installed. And this is perfect because then in the postlude you can then have the entity variable test set as the empty array, and that can take care of cases of where you don't have to do this anymore. Get rid of that. I'll register it, and I'm going to have to delete the this rule set, because remember, this is raised when the rule set's added. It was already added, so there's no way I could initialize it after it's been added. So I delete it. Now I'm going to install it again, and that rule should have ran. And if we look, yeah, test is already the empty array. We can go here, right, and add to it. You'll see that, right, there's no issues in doing that because it's been taken care of. I've already initialized it to the empty array. And just to show you guys that these are truly persistent variables, right, I can kill the Pico engine. See that it's killed if I go right here, refresh the page. If I start it again, if it's truly persistent, those entity variables should still be the same. So, right, we'll go to that rule set, and they're still there. So hopefully I was able to show you guys what the cool things you can do with these persistent variables, and hopefully you can see the difference between an entity variable and an application variable. You'll probably find yourself using entity variables way more than application variables. So now we can talk about array and map operators.
Okay, so we're going to talk a little bit today about using map, array, and string operators. So these are super helpful when manipulating data, especially because in Pico engine there aren't traditional loops like you're probably used to, but we're able to loop over arrays and maps. So what we're going to do today to make this a little fun is I've created this stops rule set, and it has we're going to pull data from the UTA's data stream, and we'll manipulate their data using maps and array operators and string operators so that we can get useful information out of it. So to start, I actually have, we're going to do so I've already created a little skeleton of our program. We're going to have a stops function, a stop data function, and then this rule that we'll call to pull the stop data. And I share both stops and stop data, and then I also added them into the testing tab. So you'll see we'll be using those. So the first thing we're going to do is I have right here a URL that we're going to need. That's where we will pull the stop data from. So let's do an HTTP GET. And that's the URL. I'll include that in the comments so that you guys can see how to do that. And so let's just register that right there and see what we get. So we'll go to testing, stops, and stop data. Oops, I put that in the wrong function. Sorry about that. Okay, take two. So we stop data. It'll take a second. It'll tell us, we got that HTTP response. So the main thing we're going to do is we'll pull out the content, and then let's do a .decode because that's going to be in JSON format. Register that, and we will try it again. And now you'll see you have this big long string. So that is pretty hard to just do anything with it right now. But something that we notice is each line has this /r /n. And so something we can do if we want to split that up is we'll be using the split operator. Now this is a string operator. Let me pull up its documentation so you guys can see. So pretty much what will happen is if we call split on a string, we pass in a regular expression as the parameter, and it'll use that as the limiter to split up the string, and it'll turn it into an array of strings. So that's the first string operator we'll be using. And again, I'd like to encourage you guys to all use the KRL manual. Go to the string operators, map operators, and array operators for more information on all of these. So we'll do a split, and we will do regular expression, and we're just going to split on the comma. Or sorry, not yet. On the /r /n. Okay, now let's save that, register that, and see what that looks like. Okay, so now you see something a little bit more interesting. Still a lot of data, but at least it's not one long line. And so the next thing that we'll do is you'll notice this first one is the headers. So we'll actually pull that out, and here let's set this equal to variable. We'll just call it data for now. And this next line, let's say headers equals data.head, and then we'll split that as well. Except this time we'll split it on a comma because this is one big CSV file. And then if we just want to return headers, so we can see what that looks like. You'll see I have this in the headers binding. Okay, so then the next thing I think we'll talk about is the filter function for the filter operator for arrays. So sometimes you'll get huge arrays like this, and you get huge arrays like this, and you don't want to deal with all this data, so you want to filter through it. And so the next operator we're talking about is the array operator filter. So what it'll do is it'll loop over every single element in the array, and if it matches the, or if this, whatever expression you put in returns true, then it'll keep that element in the array. If it doesn't, then it will not keep it. So in this example, if 3, 4, and 5, the operation has to be less than 5, so it'll just return 3 and 4 because those will both return true, whereas 5 will return false. So let's try to do that. And so to filter through this, it's just a lot of data, so to keep it fast and efficient, I think I'm just going to filter through all the ones that start with number 8. That's the first one. And also because this way I can show you guys how to use a substring operator. So what you want to do is do a dot filter, and then this filter function actually takes a function as its argument. So you'll want to do function, and then give it an argument. I'm just going to give it x. You should probably name it something better, but that's all right for right now. And then what we'll be doing is we'll be checking if the first letter or character in the string is the number 8. And so the way I'm going to do this is I'll have x, and I'll do a substring, and then pull up the string operators. So substring, we can just use it to grab part of a string. So if you were to add one parameter like 5, it would go into the 5th character and then take everything after that. If you do 2 parameters, it'll go to 5, and then it'll go 4 characters after that. And then you can also do negative and different things like that. So let's do substring, and all we want is 0. From the 0 point, we just want 1 character, and then we'll do an equals to 8. That's all we'll do. So let's register that. And you'll see when I do the stop thing, it'll only return, elements of the array that the string started with the letter 8. Okay, so the next thing we're going to want to do to this data is we are going to use another array operator. This is called the map operator. I'm going to pull this up over here. And so the map operator, what it'll do is it'll loop over each element of the array. And again, these operators are super useful because we don't have traditional while loops or for loops, but we are able to loop over each element in an array. So this one, for example, we have the array 3, 4, 5, and the function they're passing into the map operator is x plus 2. So each element is going to add 2 and then return that. So the new array it returns is 5, 6, 7. And another important thing to note is all these array operators is they don't change the original array, but they return a new array, which you can then assign to a different variable. So with ours, we'll do a function, and I'm actually going to reuse the variable x since it's out of the scope of this right here. And I don't know, it probably is better to use better naming, but that's okay for this example. And so what we're going to want to do is first we're going to want to split each line of this data up on the commas. So we'll be doing another split. So we'll go, actually let's call it split data equals x dot split. And then the regular expression we're passing in is just going to be a comma. Okay. And then from there, we're actually going to map over the same data a second time. So we'll go split data dot map. We'll go function y, because it's in the same scope as x, so I need a different variable. And I'm going to convert each one of these into a map. So the way we do that is you create a map with curly braces, and we're going to use our first map operator, which will be the dot put. So when you create a map, you can just give it, a map needs a key and a value. So let's say key to value. That's totally fine. But what if I want this key to be a variable, like if I wanted it to be x? Well, if I just type in x right there, it's going to give me a parse error. So the way we have to do this is using the put operator. Put that right back up. And you'll see if I were to have, or when you put, you can put in the key and then the value. So what I could do is just do an empty map and then do a dot put. And then here I could put x as the key and then value is the value. And that would be totally fine. So let's put, what we're going to do is for each element of these, so I don't have the headers up right now, but I think this is stop ID, stop code, and then stop name or something like that. So what we want is we're going to grab each element of the header, so it'll be a map that'll say stop ID, and then it'll point to, or the value will then be this, and it'll be stop code as the key, and then that is the value. So let's do a dot put, and the way we're going to do this actually might be a little bit tricky. So let's go headers, because we store the headers up here in the headers binding. And we'll do split data dot index y. Now let me explain that a little bit. If I come back to the array operators, there is this index operator. And so pretty much if you have an array and you meet the index of 5, you can just do c dot index of 5, it'll return the index of that element. So what we're doing here is we're mapping over an array. And so this is the specific element. I need the index of this element in that array. So I do split data dot index y, and that'll give me the element. So doing that, that'll give me the name of the header, and then the value that I want would then just be y. So let's see what that looks like right now. So you'll see now I have for each element, it's an array, and the array is an array of maps, and each map would be like stop ID to the value of the stop ID, stop code to its stop code, stop name, and so on. But what if I don't want this to be an array of maps? What if I just want it to be one long map? Well, what I could do, I can go to the array operators, and there is a reduce function, or reduce operator. So what this will do is it'll reduce an array down to something else, and you pass the function explaining how to do that. So for example, this will loop over each element, it'll pass an A and B. And so the first time it loops through, it'll get 4 and 5 as A and B, and it'll return 9. The next time it goes through, 9 is the A, and then 6 would be B, and it'll add 9 to 6, and you'll get 15. And so we're going to write a function that uses, that will pass to the reduce operator, and it will combine each element of this array, which is a map, into one big map. And so the way we do this is we'll go dot reduce. Oops, let's actually do this. We'll do it right here outside of where we map over it, because we want this. We want it to look like this, so we'll do it outside of that map. So right here we'll do dot reduce, and then we'll pass it a function, A and B. And what we'll do is we'll just do A dot put B. So we're going back to that put operator, which if you were to put a map right here as an example of A dot put B, it'll put into the map A everything in B. So when I do that, what's going to happen is looking at this as well, stop ID. So it'll have this map, and then it'll put this key and value into this map, and then this key and value into this map. And so it'll combine all down into one map. And so let's register that and see if it worked. And it did. So now each element of the array is one map. Perfect. Okay. And then the last thing that I want to do, this is also going to be using the reduce operator. It's a little bit tricky though, is we want to combine this big array, this whole thing, into one map using this as the value, and the key would just be the stop code. That way, if we're searching for a stop, you just type in the stop code, and then it'll give you, all the information about that stop. And so what we'll do is, like right here is where we'll do a dot reduce. And I'm going to want A and B again being passed in, and I can reuse those variables because it's in a different scope. And pretty much, so you might be tempted to do an A dot put B. Let's see what happens when you do that. If you were to do that, you would end up with just, one key value pair. And the reason why is because, let's comment this out. The reason why is you'll have this map right here. And if you put stop ID into it, it's going to overwrite the stop ID that's already in there. And so you can't do that. Oops. Instead, what we'll do is we will say, or we could say something like A dot put, well, let's split these up into 2 different variables. So I'm going to call them 1 and 2 instead of A and B. And so what we're going to do is we'll say 1 is equal to, and we're going to create a new map from A. So we'll use the put operator again, and we're going to do A's stop code. So what we want is this stop code to be the key, and this whole thing would be the value. And I'm going to show you guys another map operator. It's the get. So with get, you're able to just get a specific value out of a map. And so if you have nested maps like this, it can be extremely useful, because if I want to get, I like cheese out of there, then I would have to do a.get and then just pass in one array. That would be foo, bar, and 10, because we would do foo, and that would take us to here, and then we do bar as the key, and then 10 as the key, and you would end up with the correct value. You can also just use, so what we would do is a.get and then stop code. But you would also be able to just do something like that, like that to get the stop code. But we're going to use the get operator. So be that, and then a. And then if we were to do 2, do the exact same thing. b.get stop code. That actually needs to be outside of that. There we go. And then we can do 1.put 2. And we are getting, oh, we forgot to close this guy as well. There we go. Now, if I do that, it does give us what we want, but you'll notice you'll start getting null on all of these because, well, our main issue is, this works fine on the first one, but once you get to the second map, which would then be a combination of the first 2 elements of the map, then you can't just use the same code. So what we'll probably want to do is use a ternary operator. So let's look at this and kind of look closer at what's happening. So the first time you do this, you get 2 objects that look like this. And the next time you'll do, a.put, or you create the new map with a and then the new map with b and combine them. But a was actually already an entire map itself. And so then when you try to get a stop code, it gives it null and it just creates a mess. So we're going to use a ternary operator here, and we're just going to check to see if it has a stop code. So we'll do a.get stop code. And we'll make sure it's not null. And if it's not null, then we'll do the ternary operator and we'll get what we, for the code we already wrote. Otherwise, we'll just do a. And now if we do that, you'll see we end up with what we were hoping to have. So yeah, another way to kind of look at what was going on there is, let's see if I just cut that out and do it. You'll see it. Let's make sure it's actually doing it. Yeah, so it looks normal, but if you go all the way down to the last element, you'll see it actually didn't get put inside the map. So that's why we need to do that ternary operator, so we get it when it's just a single element, and then when there's multiple elements. Okay, and so now we have this stop data function that is, the main. That's the main code that we're going to write. That's pretty much everything. The last thing we're just going to do is with this full stops data is we'll have a pre-block, which will grab some data, and we'll just set that equal to stop data. And then we'll have an always block, and we'll present entity stops to data. And then up here in the stops function, we will just do stops, and then we'll do a .get, and then we'll pass in the stop code. Now, if I come up here, actually, something we're going to do is we're going to cut out this filter. So we were filtering just for the stop IDs that started with 8 just to keep our data small so it's fast. But if I take that out, or maybe I'll just comment it out. So that'll still work. And now this will take a little bit longer. But if I call or raise the stop UTA full stops data, and give it a second. It might take a little bit of time just because it's pulling a lot of data and moving over it multiple times. Okay, now it's done. And now something cool we can do is if I have Google Maps open here, and this is right off BYU campus. If I were to look anywhere on the map now, and if I see a bus stop, I can click here, and you'll see it'll give you a stop ID. Now, if I were to come here and search that stop ID, then you'll get all our stop information for it. And you can do that with any stop on here. There's a ton of stops, so something a little fun to play around with. 093. There's the stop data. And so just like that, we pull up the latest UTA transit data information, and we manipulate it into a map that we can use using map, array, and string operators.